In this video, let us see cart-hose paradox. A hose is pulling the cart in the forward direction. Then, as per Newton's third law, for every action there is an equal and opposite reaction. So, cart is pulling the hose in the backward direction. Then many students used to ask, the net force is zero, then how can the cart be accelerated? This is because of the wrong application of Newton's second law and third law. So before we apply Newton's second law, we should have an idea what is the system. Now this can be explained in three different ways. First, let us consider cart and hose as a system. Then we have to identify the forces acting on the system. The external force acting on the system only can produce acceleration. Now, hose is pulling the cart in the forward direction. Then cart is pulling the hose in the backward direction. When we consider cart hose as a system, these two forces are internal forces. The force exerted by the hose, then force exerted by the cart. So these two are internal forces, and internal forces, total internal force is zero as per Newton's third law. But internal forces cannot cause acceleration. We have to consider the force acting on the system. So now first let us consider cart and hose as a system. Next one, hose as a system, then cart as a system. First together, cart and hose as a system. Now let us identify the forces acting. Now cart and hose as a system. So mass of the cart is represented as mc, and the mass of the hose mh. So total mass mc plus mh. Then multiply by acceleration due to gravity. So this is the force, gravitational force acting on the system in the downward direction. Then the force exerted by the rod on the system, that is acting along this direction. So it's an external force acting on the system. Then it can be resolved into two components. It's a parallel component. Fr is a parallel component. This is the force exerted by the rod on the system. Then this is the perpendicular component. Then this perpendicular component will balance the weight. The gravitational force is acting in the downward direction, and this perpendicular component will balance. Now there is a force in the forward direction. So because of this, cart hose system is accelerated. So while applying the Newton's second law, we have to consider the force acting on the system, not by the system. So this is one way of explanation. Another way, considering the hose as the system. Now let us consider hose as the system. Then we have to find the various forces acting on the system. Mass of the hose is mh, then multiply by acceleration due to gravity. So you will get the gravitational force acting in the downward direction. Then rod is exerting a force on the hose. Because the hose is exerting a force along this direction, then force exerted by the rod on the hose is along this direction. So it can be resolved into two components. This is the parallel component, and this is the perpendicular component. Then this perpendicular component will balance the gravitational force acting in the downward direction. Then when we consider hose as the system, we have to consider the force acting on the hose. So this is the force exerted by the cart on the hose along this direction. Then this is the parallel component. You can see this is more than this. So there is an unbalanced force acting along this direction. So hose will be accelerated in this direction. So while applying Newton's second law, to consider the force acting on the system, not by the system. Now let us consider cart as the system. Then we have to identify the forces acting on the cart. Mass of the cart is mc into g, that is the gravitational force exerted by earth on the cart. Then force exerted by hose on the rod is along this direction. Then force exerted on the cart by the rod is along this direction. Now we have to find the force exerted by rod on the cart, that will be along this direction. On the hose, that side. On the cart, this side. Now we have to resolve this into two components. This is the perpendicular component and this is the parallel component. Now this is the force exerted by hose on the cart. Force exerted by hose on the rod is along this direction, but force exerted by hose on the cart is along this direction. Now you can see this is larger than this component, so the cart will be accelerated along this direction. So for applying the Newton's second law, we have to consider the force acting on the system. If there is an unbalanced force, system will be accelerated. So this cart hose paradox can be explained in three different ways, considering cart hose together as a system, or hose as a system, or cart as a system. Thank you for watching.